It has the. Oh, sorry. Last class. No, wait. I was in the bathroom. Now you just walk, so I learned how to keep one sided. Go to the bathroom. Wasn't afraid to get up to.
Okay, guys, I think they're ready to go. Give them their attention.
All right. Good evening, students. Hope everyone's staying dry. It's been raining cats and dogs all day.
Yeah, we're not here to talk about the weather. We're here to learn about lines.
Anyway, let's explore some patterns of lines. All right, everybody. I'm going to walk around with the packet. Go ahead and put your name on the top of it. We're going to be using this packet the entire lesson. When you get it, go ahead and start the first equation. And then once you're done with that, just put your pencil down.
The first equation actually is just a review of what you've been learning so far in the last lesson. This will help to just bring it all together and then start what you're learning about the patterns of lines. So just trying to see if you can find the equations along, and then we'll talk about it.
All right, so does anybody think they have the correct answer?
Y equals 2x minus 3.
Great job.
That's correct.
So as you can see from here, when you look on your packet, the y-intercept is at -3, and then the slope, which you learned was rise over run, is up 2 and then over 1, so it's just 2x.
Okay, now for the next part, where it says directions, graph each line using the equations below. Eric's going to model the first one, so you guys get the gist of what to do. And then you guys are going to do the second one in pairs, so you guys can pick a part there and go and work on that. But first, Eric's going to model the first one.
So let's take a look here at this equation. We've got y equals -5 plus 3x. So like we said before, you guys have learned as well that the y-intercept is the -5, and then whatever's attached to the x is the slope. So we'll go over here down to -5. And then the slope, which will go up 3, and then over 1. And then from here, hopefully everyone's following along in their packet. You can just connect the dots and hopefully make a straight line. And somewhat. So from this equation, we can see how to graph the lines and make sure that we follow, like we said, the y-intercept and then the slope. So now, with your partners, go ahead and try the second problem, and then we're going to take a look and see if we can see some patterns or what's interesting about these lines and see if we notice anything.
Guys, try not to work ahead. I know some of you like to do that.
Looks like most of you finished graphing the second line here. Does anyone notice anything about these lines? Is there anything that's interesting about them? Go ahead.
They have the same slope.
They do have the same slope. So why don't we Go to the next page and see what this will look like if we take both of these equations and put them on the same graph. I know it might be a little bit difficult, might have to flip back and forth, but can someone come up and graph the first line for us on this coordinate plane, and then someone will come up and graph the second line, and we can look at them all in one plane and see if we can find out more and what the same slope might do to the lines. So would someone like to come up and graph the first line? You graph the first line that we just worked on, and then from the previous page, yeah? The second line, if you want to take it back up. That's fine.
All right. What do you guys think? Do they look like they have the same slope? Yeah? I'll agree with that. All right, so now underneath that, it said, what do we notice about these lines? As we said, they have the same slope. You guys just notice any other similarities that they have?
Yeah, so what can we learn from these two lines that have the same slope? What does that mean? Does anyone have any idea from these?
They don't intersect.
They don't intersect. Also, what else could you call it? There's another name. The lines are parallel. Great. It's great. So what we can learn from this is that two lines with the same slope are going to be parallel. There just might be different spots on the graph that they will be parallel.
All right, so now if you guys flip your page, in partners again, you guys can do the entire page, and then once you're finished, go ahead and just put your pencils down, and then we'll move on to class from there. We'll walk around if you guys have any questions.
Make sure to discuss with your partners if anyone is struggling, so they might be able to learn from you as well. I know it's a great way to teach your partner, and then they can learn from your insight as well. Just make sure to keep thinking about what we can learn from these lines and what you see is happening to these two lines on the graphic. Looks like most of you have graphed both of the lines in the one. So why don't you turn and talk and just see what you have learned about these two equations, and then you can kind of gather some ideas and see what the two different slopes mean. some good mathematical terms used. I've heard of negative, I've heard inverse.
It should be.
Find out.
I'm taking all credit for that one.
We're gonna find out about that. That's all right, I think everyone's discussed these problems for a while here. Andrew, can you give us some insight on what you found? I heard you and your partner were talking, had some really good ideas. Can you discuss with everyone else here?
Well, first, if you notice, the two slopes are inverse of each other, and they also have the opposite signs. So when you graph both of them together, they intersect, and it almost appears that they create a 90-degree angle.
Really good, that's really good. Can someone retell what Andrew has said so that we can all make sure we understand what's going on here? Sarah, can you retell for us?
The two lines are, the slopes are inverse of each other, and when you graph them, they're perpendicular.
Great, thank you, that's really good. Also, we heard over here, what did you hear about the lines?
Oh, and theta are perpendicular. Kate suggested that.
Oh, sorry.
There you go.
Perpendicular is great, that's exactly what we're trying to figure out here.
All right, now we got that. Can we have two volunteers to come up, put those up on the board, please? Thank you, Andrew.
Have the graph just so we can make sure everyone's on the same page and has the same graph. You know, we had some good insight already, but it's always good to make sure that we have the actual graph in front of us. It's a good idea, predicting. Everyone all ready here? Just make sure to compare your graph with the
It didn't come out straight.
That's all right. Okay, so if we turn to the last page here.
All right, so first off, did everybody's answer look like that? Something like that? Yeah? All right, good.
Little messy.
So once again, we know that these are perpendicular. Creates a 90-degree angle like that. All right, now if you guys look, we have rules. There's two of them. Let's just do this together. For the first one, two lines that have blank slope are parallel. Does anybody think they know the answer to that one? Anybody?
The same.
Yes. All right, good. And then for the second one, two lines that have blank slope are perpendicular. Different? Good. Okay, you can say different. Anybody else have a different answer for that? There can be more than one for that.
Try to look back. Remember we said here, the numbers, the slope, we said it went from a -3 to a positive 1/3. So what do we call that when you change its signs and then also becomes a fraction? Did anyone know? That's a good idea. Also, go ahead, Tori.
Opposite reciprocal.
Opposite reciprocal, great. That's a new word you might not have heard today. So now we know that when it goes from a negative to a positive fraction, that's what we call opposite reciprocal. So you can put that in here at the last part where it says two lines that have opposite reciprocal slope are perpendicular. And you know that perpendicular means they create 90-degree angles.
Can you prove that that's a 90-degree angle? How much you need that? How about you justify to me that that's a 90-degree angle?
I'm not following. Is it because of Andrew's drawing? Or what?
No, I'm just asking for a justification as why you believe it's 90 degrees. What makes you believe it's 90 degrees, other than that it's the opposite reciprocal?
Well, I mean, it's how, I mean, I don't know. It's opposite reciprocal, that's what happens when two lines cross opposite reciprocal. When you have one slope and then the opposite reciprocal slope, it creates a 90-degree angle.
Is there anything you could use to show to me that it's 90 degrees? Or maybe some of your students might be.
So what we try, I'm not following the question.
Okay.
This is just kind of a guess, like, if you could, like, take the points, kind of rotate it, and then if you put it over the x and y axis, it lines up perfectly with the x and y axis of the 90-degree angle, so.
Anybody else?
That's a good idea.
Okay, take some more.
Does it take the edge of a piece of paper, put it up there? This is just where.
I mean, you should be able to see from your graph here that it's created a 90-degree angle if you put them with the ruler should build there.
Good.
You know that a line is 180 degrees, so you can see that it cuts the line, the angle in half, which makes it 90.
I mean, I don't know if middle schoolers would know that, but that's a good idea.
I think they would buy the paper idea. If you took
True.
a piece of paper up there and.
I mean, I'm just going on what we learned from the previous lesson, trying to apply that as well. So, all right, now that we've learned some patterns of lines, I hope this helps. Now you can see how different slopes and different lines work. Like we said, the same is parallel, opposite reciprocal, perpendicular. And for the final lesson, we'll turn it over to Lindsay and